Just okay, then we'll discuss the main points. So yesterday, somewhat we have covered the syllabus. Now, straight away we'll discuss about unit graph. So hydrographs, unit hydrographs, then the derivation of unit hydrographs, limitations of unit hydrograph, then synthetic unit hydrograph, instantaneous unit hydrograph. So what's the mean by hydrographs? So hydrograph is a response of a given catchment to a rainfall input. It consists of flow in all three phases of runoff. One flood hydrograph, that's a we see the component parts of the hydrograph. Base flow, you separate the base flow from the total runoff, you are supposed to get direct runoff hydrograph. So if you see the graph, discharge versus time. So let's say point A, B, it's a peak. Point B is the peak flood. C is the point of inflection. It's a direct runoff. Of course, everything is already studied. But anyhow, please see carefully like this. So MA equal to base flow separation. This line, it's MA. Then AB equal to rising limb, BC equal to crest segment, CD equal to falling limb, right? DN equal to base flow recession, DN is a base flow recession, points B and C are inflection points. Then direct runoff hydrograph. So it's obtained by separation of base flow from flood hydrograph. It's also called as surface runoff hydrograph. So depth of runoff equal to volume of runoff by area of catchment. That's so volume of runoff equal to area of direct runoff hydrograph. That is like this. So then one of the important term called as effective rainfall. So the effective rainfall defined as that rainfall is neither retained or the land surface. It's not infiltrated into soil. It's called effective rainfall. So in pi index also, pi index is the index above which runoff volume equal to rainfall value. Then coming to the unit hydrograph. So unit hydrograph is the hydrograph of direct runoff hydrograph resulting from 1 unit depth of rainfall excess occurring uniformly over the basin and at uniform rate for a specified duration. So this is called as d-hour unit hydrograph. So this is called a unit hydrograph. Next. Of course, assumptions of unit hydrograph already in theory questions, applications of unit hydrograph. It's also important in university examinations also. So by using unit hydrograph, one can easily calculate the direct runoff hydrograph. Then effective rainfall hydrograph test. Oh, see. The ordinates of a 3-hour unit hydrograph at 1 hour interval starting from t equal to 0 or this is the ordinate 0, 3, 6 like this. So of course it's a trapezoidal rule. Solution also see maximum of ordinate 8 meter per second. Effective rainfall in all 3 hours. You know the 6.6 minus 0.23 means 0.2 meter per 2 millimeter per hour. Base flow is 5 meter per second. So what's the peak flow? 8 into 6 plus 53 meter per second. See, a 9-hour unit hydrograph of the catchment is triangular in shape with a total time base of 36 hours and a peak discharge of 18 meter per second. So the area of the catchment means, so let's draw the triangle. So area of BH at time of base and 36 hours, peak and 18. That's equal to equating to area. A into 10 power 6 means that's area of the area, of course, don't know, into 10 power 6 converted into meter square. Unit hydrograph means 1 centimeter effective rainfall. That is 1 by 100. So equating it, you are supposed to get A directly, like this. Next, the average rainfall for a 3-hour duration storm is 2.7 meters and the loss rate is 0.3 centimeter per hour. The flood hydrograph has a base flow of 20 meters per second and produces a peak flow of 210 meters per second. The peak of a 3 hours unit hydrograph is, see, step by step, see, rainfall depth in 3 hours. See, 3 hours is 2.7 centimeter. Loss rate how much? 0.3 centimeter per hour. Our total loss per hour 0.3 centimeters. For 3 hours, 0.3 into 3, 0.9 centimeter. So rainfall excess means total rainfall minus loss. What is meant 1.8 centimeter in 3 hours. Now, flood hydrograph peak flow in the 210 meters per second. Base flow in the 20 meters per second. So if you add flood hydrograph plus base flow, you are supposed to get direct means flood total hydrograph. Right? So flood hydrograph minus base flow is supposed to get direct runoff hydrograph like this. So net peak means 210 minus 20, 190 meters per second. So 190 meters per second is due to 1 centimeter effective rainfall. So for 1 centimeter, unit hydrograph like this. 190 meters 1.8, 105 minus 105.6 meters per second. Of course, these are all the numerical equations. I will share it to you for practice. You can work out. It was problem. Need to get a solution. A direct runoff hydrograph in response to 5 centimeter rainfall excess in a catchment is shown in figure. The area of the catchment expressed in hectare is, see, one is triangular in shape. That is called half BH. That you know that half B into H because 6 direct runoff hydrograph response 5 centimeter rainfall excess shown in figure. The catchment is like this. So 6 hour duration by 6 into 3600. So area into 10 power 4 square meter into 10 power hectares into 10 power 4 meter square into 5 centimeter effective rainfall and 5 by 100. So equating it, you can get directly A like this. Okay, this may not cover in the university syllabus, so that's why. So aquifer. So, its aquifer is saturated formation of earth material, which is not only stores water, but yields it in significant quantity. For example, sand. So, it is transmit and to store it. Aquitard means is a formation through which only seepage is possible. Thus, yield is insignificant compared to an aquifer. It is partly impermeable. Example, sandy clay. Aquifer means a geological formation which is essentially impermeable to the flow of water. Example, clay. Aquifer is a geological formation neither porous nor permeable. So, sheet rock. So porosity of the specific field and specific retention CN equal to SY plus SR, coefficient of permeability equal to K into B, right? So unconfined aquifer P equal to, it's a very important formula, pi into K into R2 square, whatever it is, you use S2 or Z2, whatever it is, some textbook S2 or Z2 by log R2 by R1. Confined aquifer is 2 pi K into B, Z2 minus Z1 by log R2 by R1. I think we may have the webinar, so please join in the webinar. So, Sari is asking for, I will finish it. For 5 minutes, because we may have a webinar at 2 o'clock. Okay, then, see, you could do 2 observation wells penetrating into confined aquifer are located 1.5 kilometer apart in the direction of flow. Heads of 45 meters and 20 meters are indicated in the aquifer is 30 meters per day, coefficient of permeability. Right, and porosity is 0.05. The time of travel in net pressure from one well to another is about First of all, right hydraulic radius I equal to h by L means 45 meters 25 differences 45 minus 20 by L this one. Coefficient of permeability is 30 meter per day. As per Darcy's law, V is equal to K into I, we can get 0.5 meter per day. Seepage velocity V is equal to V by N. That's called velocity by porosity. So 0.5 by 0.25, 2 meters per day. So velocity equal to discharge by time. You have to the time equal to 1500 by 2, that's 750 days. Next, soil has a coefficient of permeability of 0.51 centimeter per second. If the kinematic viscosity of water is like this, the intrinsic transferability that is law. So this is the right formula. We know that the soil mechanics also. So finally, radius of influence of unconfined aquifer having 40 meters thickness, if uniform discharge of 20 meters per minute from a well of diameter 20 centimeter, K equal to 0.02 meter per second, drawdown is 4 meters. So let us see. So radius of influence, find out challenge, or what is radius of influence where the drawdown is 0. That's called various directly applied to the formula Q equal to 2 pi into K h2 square minus square log R2 by R1. So you are supposed to get R equal to 30.8 meters directly. So please note down it. Just solution, please note down. No need to write the problem, at least solution. Both 7 and 8, please try to read the problem, then solution directly. So second 8 problem, so Q equal to pi into K, Z2 square minus Z2 square or S2 square minus S2 square, whatever it is, by log R2 by R1. So as it is, whatever the given data, you please substitute. Finally, you can suppose to draw down. First solve, please take a right solution. Read the problem, take a solution. Coming to irrigation. So irrigation in general defined as the supplying of water by artificial means of the cultivation of crops and the works required to give effect to supply or irrigation works. Of course, some textbooks have given separate definitions. We know that irrigation is the artificial application of water to the land according to crop requirements throughout the crop period for full-fledged nourishment of the crops. So what's meant a crop period, base period? So it is instead of sowing to harvesting, right? First watering to last watering is base period. Instead of sowing to harvesting in days is called crop period. So see QT equal to area to discharge. Just please note on main points. So delta equal 8.64 B by D in SI system or whatever it is. So Rabi season 1st October to 31st March. Kharif season is April to September or whatever it is. So some of the definitions are cultivable command area or not cultivable command area like this. Irrigation efficiencies, water delivered or water supplied, efficiency of water conveyance efficiency, water application efficiency, water storage efficiency, then water use efficiency. Any problem solved and just you will finish it. You'll stop it. So a lift irrigation scheme using a discharge of 96 meters per hour is planned to raise the crop with an average delta of 0.375 meters. Intensity of irrigation is 60%. Assuming 3,600 hours of working of the tube well of a year, the cultivable command area in hectare is. Please note on the solution. Just take a solution. Read the problem. Take a solution. ఇక్కడ A in hectares into 10 power 4 square meter, right, into 0.6, 60%. Area 60% is cultivable, right? Intensive irrigation into 0.7 means delta, total depth. So area into depth will give value. 60% means 0.6 only intensive irrigation. That will give to 96 meter per hour into 3600. 60 into 60. Assume 3000 hours of working. So 96 meter per hour discharge. Total is 3600 hours. So you are supposed to get A directly.